Hi, I'm Arnie Gunderson from Fair Winds, and it's Friday, May 6th. A couple things I wanted to talk to you about today. They all relate to releases from the plant. The first one is airborne releases from the plant. The second is the explosion at Unit 3, a little follow-up on that. And the last topic of the day is liquid releases. Well, the first topic is airborne releases. And you'll recall that I've said several times in print and on TV that the Japanese are lucky that the wind was blowing out to sea most of the time during this accident and not across the island. Well, I just received an email just yesterday from a Dr. Sanjay, S-A-J-I, and he's a former member of the Japanese Atomic Nuclear Safety Commission, and he's highly respected in Japan. And I wanted to read you what he had to say about what I have been saying now for the last 6 weeks. He said two things. He said, we were just lucky due to the favorable meteorological conditions during the entire development of the accident. And then a little further down in this report, he writes one report a day and has since the accident began. A little further down in the report, he says, we were very lucky even with a large release from Fukushima 3 due to the most severe hydrogen explosion that could have induced a heavy land contamination. This resulted from the wind direction toward the sea at the time of the release, although this must have resulted in a wider ocean contamination far from the Fukushima unit. Well, that's pretty strong words for a senior member of the Japanese nuclear establishment. But it is about 5 or 6 weeks later than I recognized it. Now, why is this important? It's important for a couple of reasons. First is that had the wind been blowing across the island instead of out to sea, we would have had an exclusion area that, like Chernobyl's, all the way across the island of Japan. Now what would have happened is roads heading north-south, major roads, would have been cleaned and you could have traveled from the north to the south. But as far as getting out of your car or living in that area, that would have been impossible. So certainly the Japanese were very lucky that the wind predominantly was blowing out to sea. Now, related to that, though, is the spin that I believe will be put on this issue by nuclear power companies around the world. And they'll, of course, say, look at this accident at Fukushima, and there really weren't the fatalities we would have expected. Well, the problem there is that the wind was blowing out to sea. And the other problem is, as Dr. Wing discussed about a week and a half ago, what you've done is you haven't eliminated the cancers, you've spread them out in a worldwide population, so that really it may be more hard to determine whose cancer is a Fukushima cancer and whose is not. But it hasn't reduced the number of cancers. It certainly has saved the Japanese from living near the reactor enormously. Now, the other thing that Dr. Sanji said was, and this I found really important, was that the explosion at Unit 3 being blown out to sea must have resulted in wider ocean contamination far from the Fukushima plant. Which leads me into the second point, and that's the condition of the Fukushima 3. And you recall I had a long video on that about a week and a half ago. I've gotten a lot of emails, and very thought-provoking emails at that. All of them agree on a couple things. That there was a hydrogen explosion, there's no doubt, but that it wasn't entirely a hydrogen explosion, and that it was a detonation, not a deflagration. And I'm interested, though, in some of the other pieces that have come out since then that viewers have sent me, and some great discussion points. The first is that if you, I was sent a frame-by-frame analysis of the explosion, and in that, if you look at the fire that's on the south side. It's the right side of the building. The flame moves out further to the right, but it also moves straight up on the left side. Well, to me, that confirms it's the fuel pool, because that's exactly where the fuel pool should be. And the outside wall of the fuel pool shows damage, which would indicate that the explosion pushed the outside wall and traveled up. But on the inside wall, which would have been stronger as it abutted the containment, it moved straight up. So take a look at the first two frames of that, and you'll see what I mean, how the flame goes up on the left, but heads out and further south on the right. So that tells me it's the fuel pool. The other thing that tells me it's the fuel pool is that this started as a hydrogen explosion, but it could not have been a hydrogen explosion could not have lifted the fuel out of the reactor. And that's because the reactor's in a deep pit and hydrogen is lighter than air. So there's no way that if hydrogen had been floating above, that it could have gotten underneath the fuel and lifted it up. So everyone who's written to me agrees that there was a violent explosion at the bottom of the pool, lifting it up. And there has been some disagreement on what could cause that. I've gotten a great discussion about a chemical reaction that could have involved uranium, plutonium, and zirconium in the fuel that could lift the fuel up like that. That's a possibility. We need some more data to prove that. I had another person say, well, plutonium melts at a lower point than uranium, and felt that there was a pool of plutonium on the bottom of the reactor. Now that could have created a criticality that could lift the fuel up. Now, in my presentation last time, I talked about a criticality too, prompt criticality. I need to talk a little bit about what that means to differentiate between a couple of theories here. When a uranium atom splits, it creates fission products, daughter products, and about 2.5 neutrons. On average, 2 to 3 neutrons. Most of those neutrons shoot out and are called prompt neutrons. A few of them take their time. They got to have their coffee in the morning before they head out. And they're called delayed neutrons. Normally a nuclear reactor works on the fact that these delayed neutrons are what perpetuate the reaction. But as I said, I think this reaction in Unit 3 was caused by prompt neutrons. Now, one of the readers suggested that we could have had a nuclear bomb at the bottom of the reactor because the plutonium would melt differentially from the uranium. Now, for that to happen, there would have to be a puddle at the bottom and a complete melting of the fuel. And I'm not sure the evidence suggests that. So my theory is that there was a prompt reaction, but that it wasn't like a bomb. They weren't traveling fast, but that they slowed down in water, and the criticality is called prompt, but it's also called moderated. And a prompt moderated reaction would certainly create just as much power as all of the other examples I've given you. There's 2 examples in history of this happening, these prompt moderated reactions. The first is at a reactor called SL1 out in Idaho. There some operators were working on the control rods, and one of the control rods blew through an operator and impaled the operator on the ceiling. That's an example of a prompt criticality. It has happened before, and I think it happened again at Fukushima 3. So I wanted to let you know as readers that I still believe my theory is correct, but there are some competing ways that a violent reaction in the fuel pool could cause a similar issue. Finally, on Unit 3, it's still possible that the reactor and containment could have been breached, and many viewers feel that that's the case. I don't, because all of the data coming out of Fukushima now indicates that the pressure and temperature inside the containment and reactor are still in reasonable ranges. So I discount that not because of the violence of the reaction, but because data since then seems to indicate the containment is intact. Now, finally today I wanted to talk about liquid releases from the reactor. Just yesterday, Fukushima 5 and 6, and now they're a long way away from Fukushima 1, 2, and 3, were still pumping radioactive water out of the basement of their turbine halls. Well, what that tells me is that the groundwater on site is contaminated. In order for groundwater to be contaminated, there's got to be a leak in one of the containments. Remember, all this water is being poured in on the nuclear reactor and is now lying in the bottom of the containment. We know Unit 2's containment is breached, and we know that water has gone into trenches all over the site. I don't think all the leaks have been fixed. It would be hard to imagine all of the leaks being fixed. The big one that headed out to the ocean is, but I am not convinced that all of the leaks have been fixed, which means that water is seeping into the ground table, and there'll be contamination on that site for a long time to come. It could also move inland. This is groundwater. It doesn't have to move out to the ocean. It's clearly moving to the north. So groundwater contamination at Fukushima will probably be the worst we've ever seen in nuclear history. The second thing is, within the Fukushima prefecture, one town is now reporting radioactive sewage sludge. I don't know how that got there. Clearly that's a very disturbing issue. It could come from groundwater, could come from rain runoff, but it is a major concern. Now, that sewage sludge was sold as construction material and has been shipped out of the Fukushima area. So some of the radioactivity is now going to have to be chased down where it went as cinder blocks and concrete blocks, and they'll have to be recovered. But that's a major concern that we need to keep track of. And finally today, I wanted to talk about the Greenpeace ship called the Rainbow Warrior. It's asked for permission from the Japanese government to sample the waters within 12 miles of Fukushima, which are Japanese territorial waters. And the Japanese have refused to allow the Rainbow Warrior in. Given the lack of forthcoming nature of TEPCO's data, I'm saddened that Greenpeace can't be getting independent data on its own ship. And lastly, about independent data, the EPA has shut down all of its post-Fukushima air inspection stations and is not inspecting fish as well. And I think if there's anything that you and I as citizens can do, it can be to press Congress to make sure that the EPA is continuing a robust sampling of data coming out of Fukushima. Well, thank you very much, and I'll get back to you soon.